Hello and welcome to this Inbetween Episodes episode. This episode is a necessity for me to be able to finish my next project. So the next project is a bit crusher that I'm building using an ADC, analog to digital converter. And by doing that, I need a really fast clock for the cycle to be fast enough, so the sample chunk resolution is small enough or fast enough. And for that, so I tried to just use a normal oscillator, which did not work. So this is my second alternative now then. The LTC1799. If you've worked with circuit bending guitar pedals and stuff like that, then you know what the 1799 is. Usually you buy it as a kit. So that's the chip right there. So usually you buy it on a piece of board like this, with an onboard resistor, capacitor, and a potentiometer. Those are quite expensive. Circuitbenders.co.uk have some, but you can buy these little rascals on most of those Chinese part sites, or any mouse or anything. You can buy them anywhere, and they're not that expensive there if you just buy them like this. However, they are SMD and they're really, really small. So today I'm going to try to solder this onto one of my SMD to throughhole boards. And if you've ordered anything from me, you probably have one of these, of some of these three versions. I've done a few versions over the years. This one was the first version, which only had footprint on one side, and then came the second one where I got the really tiny one, MSOT, and all these on the bottom side, bottom side. And then I have the final version 2.3, which the top side looks the same, but on the bottom side I also added, I don't know the footprint, but it makes it possible to add the AMS 1117 3.3 volt power adapter as well onto this one. So there's like so many different footprints on this one. It's really awesome. And you can also, I'll put the link in the description where you can download Gerber files to print one of these, or order these files from any PCB manufacturer. You order, I think you can fit 64 on one piece of these. So if you buy a 10 pack for, what is it, $5, you have 640 of those. That should last you a lifetime, I think. For this purpose today, it doesn't matter which of these boards you have, because we are going to use the top side for the SOT23, I think it is called. SOT23, yes, that's the one. It says right there on the datasheet for this chip. So we're gonna put it there and gonna solder that in place. So I think the circuitbenders.co.uk version is just this typical application from the datasheet, and this is the thing I'm going to do. So it's really simple. We have voltage plus, and we have ground there. We have a capacitor in between here, 0.1 microfarad. We have a resistor here, greater than 3K and less than 1 mega ohm resistor. So I have a 1 mega ohm resistor right here, and I have a 3K resistor right here. So these in series will make sure we will get below 3K, above 3K, sorry, although we will go above 1 mega ohm. I don't know what that will do, but we'll just be careful when we go to the outermost regions of this. I also have this switch, which is on, off, on, which means that we can do the little divide by 1, divide by 10, divide by 100 thing down here, and this is for the clock pulse. So this means we can get a clock pulse from 1 kilohertz to 33 megahertz with these few components here. So we're gonna build this together, and then hopefully with this I can then continue my bit crusher effect. So let's get to it and solder this together, and we'll see this in action in a bit. Clean start, a new board, and I'm gonna add some flux because people say that is good. So let's add some of that. And let's hope they are correct in saying that. Again, need some solder on my soldering iron. I think that worked much better actually. Wow, flux did the trick. Now it just took just over a minute to do this. And we should continuity test these so we don't have any shorts. Not there. So apparently there's a short. Yep. Can't be a short there. Could be on the underside. It's not. Okay. Let's see if we can fix that. And the short is gone. Good. So let's remove this one, even though that was good to have. But now we're working with through-hole components from now on. So between pin 1 and pin 2, I just have to make sure I'm using the right pins here. So okay. So that is pin 1 and pin 2, those two. Between there should be a 1 microfarad capacitor. And then between pin 3 and pin 1 should be a 3K ohm resistor. Let's see if we can fit all that in those holes. Guessing not, but we can always try. Oh, we could. But then we have a 1 mega ohm resistor that should be in the mix as well. And that one is not going to fit there. I know that much. So let's add these two. There we go. And then we can use these, let's see, the ground one, we're gonna have to connect it to something though, because it's ground, so we need to connect that to voltage plus, to ground and voltage plus. So voltage and voltage plus on this pin right there. And but we need, so we put this one as well between those two. So if we add it like so, I don't know which way it turns though, which if 3K is a little and 1 meg is a lot of or fast, or the other way around. So let's just pick one of the outermost pins and the wiper pin, and we solder them onto here. Something like so. Yeah. Alright, so then we need this switch as well. And that is pin 4 and plus 5 volts and ground again. What do you know? So then we need, let's see, pin 4 to the middle. Now, of course, if we know exactly what speed we need the clock to be, this switch is not needed. But I'm thinking I can make this as a standalone testing jig that I can use to try different speeds, and then when I know which one I need, then I know which way this switch should be and what the resistance should be as well. And we forgot to add more cables here, so it's power cable and ground. And then for the output, I'm thinking of adding just a DuPont, half a DuPont cable, because as I said, I want to use this for other devices when I want to check what clock to use. Before I go and show you how this works, I did a super rookie mistake, of course. I put the resistor and the potentiometer, I put them in parallel, not in series, which they're supposed to be. So as this works, but it doesn't work as we want it to, because it needs to be 3K and then the 1 meg ohm pot and then into the input. So I need to remove this resistor here. And let's see if we can fix this like so. That we remove it from here. Connect it that way, and then onto here we can twist this out a bit. Much better. This should work much better. Now let's go and look on the modular. So this here is my next project, a bit crusher, working mainly with the ADC 0809, which we have here, which we'll talk about in the next Modular in a Week episode. Here is the little LTC1799 circuit we did just now. So let's turn on the power here. And I have white noise going in here. So input is this, and output is right now this. And here we, so now here we hear that we can actually set, yeah, and if we go to over 1 meg, it flats out. But we can actually set the bit rate here, but it's a quite low bit rate, I think. So we do times 10. Oh, this was times 1. The other one was times 10. Let's do times 100 then. Or am I doing this wrong? This should be... No, apparently I'm doing it wrong. This is divided by 1, I guess, then. So here we have them. One, so quite low bit rate, quick bit rate, and really fast bit rate. So this is input signal, output signal. That's quite good actually, but we're at maximum what this one actually can handle. So we're at 33 megahertz, I think. But we can do that. We can bit sample rate reduction as well. So awesome. This is such an awesome little thing I think I've come up with. Stay tuned for the next Modular in a Week episode for more info on this one. This has been in between the episodes episode about the LTC1799. So stick around, make sure you are subscribing and click the bell and all that so you don't miss this little circuit in the next episode. Take care. Bye.